Welcome to myprojectbazaar.com. Our project title is a space-bounded anytime algorithm for the multiple longest common subsequence problem. In our project, the multiple longest common subsequence problem called MLCS, that is related to the identification of sequence similarity, is an important problem in many fields. As an NP-hard problem, its exact algorithm have difficulty in handling large-scale data on time and space-efficient algorithms that are required in real-world applications. To deal with time constraints, anytime algorithms have been proposed to generate good solution with a reasonable time. Based on SLA-MLCS, a space-bounded algorithm is developed to avoid a space usage from exceeding available memory. SLA-MLCS uses a replacing strategy when SA-MLCS reaches a given space bound. However, there exists little work on space-efficient MLCS algorithm. In this paper, we formulate the MLCS problem into a graph search problem and present two space-efficient anytime MLCS algorithms, SA-MLCS and SLA-MLCS. SA-MLCS uses an iterative bin widening search strategy to reduce space usage during the iterative process of finding better solutions. Furthermore, SLA-MLCS can find much better solution than SA-MLCS on large size instances. We present two new space and time efficient MLCS algorithms called SA-MLCS and SLA-MLCS by using increasing rate. Although SA-MLCS uses space efficiently, its space usage still grow exponentially. Handle the problem SLA-MLCS, a space-bounded algorithm. SLA-MLCS replaces the nodes that have been expanded in order to guarantee the space usage not to exceed the space bound. Based on SA-MLCS and SLA-MLCS, the state-of-art approximation algorithm MLCS app while finding better solutions. Compared to the state-of-the-art anytime algorithm, Pro-MLCS, SL-MLCS, SLA-MLCS can solve an order of magnitude large size of instances. It's our data flow diagram. First of all, we are going to detect what are all the MLCS problems that occurred in our project. After, we are going to detect the MLCS problems, and then we are going to identify the dominant points. Dominant points is nothing but what are the files that are included in our project, and the file size could be calculated. After the dominant points could be generated, it could be represented as a graph representation. After the graph could be generated, we are going to reduce the file size by using SLA-MLCS algorithms. After reducing the files, we are going to analyze what are the files that are used in our project at the beginning, and the size could be compared by the reduced file size. Let me see the demo of our project. Choose load.java and run file. In this frame, we are going to choose our dataset, which is named as WBKB dataset. Then we are going to choose the path and choose the file. Then we are going to view what are all the contents that are present in wbkb.txt. These are all the contents that are present in our dataset that we are chosen. Then we are going to split each and every category by course, student, project and faculty. Then we are going to split what all the information that are under in course test and what are the information that are under in student category, and also what are the information that are present in our dataset under project category and also in faculty category. So course, these are all the contents present in course.txt. Then student, these are all the information that are present under the student categories. Then project, these are all the information that are present under the project category. Then faculty, these are all the information that are present under the faculty categories. Then we are going to pre-process and pro-processing and pre-processing on each and every file. In course, these are the pre-processing data and these are the pro-processing data and these are the pre-processing data. In student, these are all the pro-processing data and these are all the pre-processing data. In project, these are all the pro-processing data and these are all the pre-processing data. Faculty,
These are all the processing data and these are all the pre-processing data. Pre-processing data is nothing but removal of stop words and unwanted contents. In next frame, we are going to extract each and every feature in every file. In course, there are 573 features going to be included or extracted. In student, 441 features could be extracted. In project, 960 features could be extracted, and in faculty, 711 feature to be extracted. Feature is nothing but number of columns or number of data that are present in our dataset WBKB. Then we are going to find the similarity between each and every files. So we are going to calculate the vector values. In vector values, course has these similarity values that are present in last column or last field. In student, these are all the informations. In project, these are all the informations, and also in faculty, these are all the changes. Then we are going to find by comparing each and every document and similarities, and we are going to find the standard deviations of comparing document D1 and D2, D1, D3, D1, D4, and also D2, D3, D2, D4, and D3, D4. So first we are going to display what are the similarity value that contains in document 1, and then in document 2, and then in document 3, and then in document 4. By calculating standard deviation for by comparing document D1 and D2, and document D1 and D3, and document D1 and D4, and document D2 and D3, then document D2 and D4, finally document D3 and D4. Then we are going to display what are the standard deviation and what are the mean values that are present in our project. These are the standard deviation that we have calculated, and these are the standard deviation formula by using similarity values to be calculated. Then we are going to find the similarities. By implementing MLCS problem, each and every similarity value could be calculated by comparing document 1 to another document. So finally, we are going to identify how much space that we reduced in our project, because it's our core object in our project. Result that we are chosen dataset named is WBKB in this size, and then the reduced file name is final, and it could be reduced to the size in this. Then we are going to check the accuracy level. It's our existing system and it's our proposed system. In existing system, Pro MLCS would utilize large amount of space and to utilize and process large amount of space to store the data. And in our proposed MLCS problem, SLA MLCS problem, the space could be reduced, and we are going to reduce the space by using the SLA MLCS algorithm that could be implemented. Thank you.